Okay, this is quite off topic, but I think it's interesting, so I want to cover it. So I set a challenge for myself and I failed it. I want to understand the spec in 2 hours. So I changed it to understand the overview in 2 hours for PCIe. This is the outline from the spec. As you see, there's a introduction. I think this is important. We should read and understand this part. And there are 8 chapters. Each chapter has an overview, and I think we should read it as well. There is a So when you look at this, you know that the protocol will have transaction layer, data link, physical layer, and power management may be related to these things to determine the speed of them. And then we have system architecture, software initialization, and the other. So in short time, I think we can just cover from 1 to 6 or 5, and this is the rest of it. So introduction, 2 main component is root complex and endpoint. And root complex connect with CPU, endpoint can connect with any endpoint such as SSD or RAM or GPU. And inside the switch, there is a bridge, and this is going to perform switching between the root complex and the endpoint. So the first layer is transaction layer. It can handle reading and writing, memory IO configuration, and it will send package to data link. So next is data link. So the main function of data link is to exchange data between these two: error detection and retry, initialization, and power management. So it may relate to chapter 5, power management. And this is the state machine, and inside each section there is a rule for each state. The next is physical layer, perform 0 parallel to 0. And the thing that I understand here is the A10 AB10B encode. So the reason we want to do AB10B is because if we have a lot of 111 here, then the signal gonna look like this. It's just like a DC. We don't want it. We want something like this so that we can separate it. So that's the reason we use 8B10B. There's a disparity if the number of 1 greater than 0. Like this example, we set positive, and if the number of 0 is more than 1, we set negative. So this is a lookup table from Wikipedia. We can try with this example. I have 11110001, and the sequence starts from the least significant bit, so it's A, B, C, D, E, F, G, H, and we break it to 3 and 5. So as you see here in the lookup table, we have A, B, C, D, E that match with this one, and then we have H, G, F that match with this. All right. So first we should bring it, look it up, and copy the code. So it's gonna be 100011, but we have to flip them. So A start first. So then it's gonna be 100011, and the next sequence is HGF here. HGF. So we also look it up, and it is 111. And in the footnote, so in this case we decide the disparity is minus. So when RD equal -1, 5 and 3 is -2. In this case we have -2. I don't know. So assuming it's -1, and then X is 17 because right here is 17. So we can use the XA7, and the sequence is FFGH. We have to flip it as well. So F0G111. Yeah, and this is the final sequence that we have. So originally we have something like this, and now we have this. But I'm not sure. Except in our case we have 1, 2, 3, 4, 5. 5 minus 2 is 2. Yep. Maybe there's something wrong. I don't know. Power management. I still trying to figure this out as well. So that's all.